A solid rectangular block has a square base of side x centimeters. The height of the block is 8 centimeters and the total surface area of the block is 96 centimeters square. In the first part of the question, it is asked to express h in terms of x and show that the volume V of the block is given by V is equal to 24x minus 1 upon 2 x cube. So in the first part of the question, I need to express a relationship of h in terms of x. So I need to form an equation of h in terms of x. And then I need to show that the volume is given by this equation. So I need to form another equation of volume which is in terms of x again. The data that is given to us is that a solid rectangular block has a square base of side x centimeters. Now if I open my formulas, this is what a solid rectangular block looks like. This is the formula for surface area and this is the formula for volume. Now it is told that the base is square and sides are x on the base. So the length is x and the width is also x. And then it is told that the surface area of the block is 96 centimeters square. So if I use my formula for surface area is equal to 2 times the length times width plus the width times height plus the length times height. We know that the length and the width are equal to x and the surface area is 96 centimeters square. So 96 is going to be equal to 2 times x plus width is also x, so x times h plus x times h. I can simplify to write this as 96 is equal to x times x is x squared and 2 times x squared is 2x squared plus xh plus xh is 2xh and 2xh times 2 is 4xh. The question asked me first to express h in terms of x. So I need to make h the subject over here. So when I make h the subject, the equation that I'll get is 96 minus 2x squared divided by 4x. This is the equation of h in terms of x. Now I need to show that the volume is given by this equation. The formula for volume is length times width times height. So volume is equal to length times width times height. Length and width are x, so volume is equal to x squared times height. The volume right now is in terms of both x and h, but I need to only show volume in terms of x only. And I already formed an equation of h in terms of x. So I'm going to replace h by this equation. So volume is going to be equal to x squared times 96 minus 2x squared divided by 4x. X squared divided by x is x. So I'll get, if I write over here, 96x minus 2x cubed divided by 4. This is the volume. In the numerator, if I take 2 common, I'll get 2 times 48 times x cubed divided by 4. 2 times 2 is 4 and I can write this as 48 upon 2 minus x cubed upon 2. 48 divided by 2 can be written as 24. So volume is equal to 24 minus 1/2 of x cubed. And this is what I needed to show over here. So part 1 is done. I have shown that volume is expressed by this equation. Now after we have shown that volume can be expressed by this equation, in part 2 I need to find the stationary value of V, and it is given that x can vary. So I need to find the rate of change of volume with respect to x, and that is given by dV upon dx. So I need to differentiate this equation of volume with respect to x, and the differentiation of 24x is going to be 24, and the differentiation of minus 1/2 x cubed is going to be minus 3 upon 2 x squared. Since I need to find the stationary value, dV upon dx is going to be equal to 0, because at the stationary point the gradient is 0. So this is going to be 0 is equal to 24 minus 3 upon 2 x squared. Now I'll solve this equation for x. Minus 3 upon 2 x squared is going to be equal to minus 24. These two minus signs cancel out. X squared is equal to 24 times 2 divided by 3, which is equal to 16. So x squared is equal to 16. Now if I take square root on both sides, I'll get x as positive 4 or x is equal to negative 4. But we know that x is representing the length of the rectangle, and length can never be negative. So I'll reject this value of x as negative 4. So my only value of x is positive 4. But the question asked me to find the stationary value of v. So to find the corresponding value of v when x is 4, I'll put this value of x back in the original equation, which was 24x minus 1 half x cubed. So volume would be equal to 24 times 4 minus 1 upon 2 4 cube. Putting all of this in the calculator would give me the value of volume as 64. So my answer is volume is equal to 64 centimeter cube. This is the answer to the second part of the question. In the third part of the question, I need to determine whether the stationary value is a maximum value or a minimum value. So whether this 64 is a maximum value or a minimum value. Because we know that stationary points can either be maximum points or minimum turning points. So to find whether it's maximum or minimum, I'll take the double derivative of change in volume with respect to x. So the double derivative is going to be d square v upon dx square. 24 is a constant, so its differentiation is going to be 0. And the differentiation of minus 3 upon 2x square is going to be minus 3 times 2 divided by 2x. 2 divided by 2 is 1. So d square v upon dx square is equal to minus 3x. The value of x corresponding to volume of 64 we calculated was 4. So d square v upon dx square is equal to minus 3 times 4. Minus 3 times 4 is minus 24. So d square v upon dx square is equal to minus 24. Here the double derivative is minus 24, which is less than 0. And whenever the double derivative is less than 0, the stationary point is a maximum stationary point. So this value of volume, which is 64, is a maximum value. So this is a maximum stationary point. And this is representing that on one of the axis I have volume and on the other axis I have length x, and volume is changing with respect to x. And when x is equal to 4, positive 4, there is a maximum value of volume, which is 64. So this is the answer to the third part of the question. The stationary point is a maximum stationary point.